we've been talking about arithmetic and geometric series, so now we're just going to look at some applications of that, looking at an HSC question. Now, HSC questions I find on some of these tend to be a little bit forced, so not that they're always realistic. For example, Heather decides to swim every day to improve her fitness level. So on the first day she swims 750 metres. But then, but that's not good enough. And then each day after that, she swims 100 metres more than so another 2 laps. So, in other words, in case we don't quite understand what they mean, she swims 850 on the second day, 950 on the third day, and so on. And the question is, we want a formula for the distance she swims on the nth day. So we have to try and pull out all the information. So let's see. A, that would be 750 the first day. D, we're adding 100 every day. Now, the general term they want us to find, hey? Okay, term n. That is, of course, a plus n minus 1d. Substituting in, tidying up, and we have our formula for how many metres she swims on a particular day. Okay. So how far does she swim on the 10th day for 1 mark?
T10.
I think we have to find T10. Substitute in 1,650 metres. Over those 10 days, what's the total distance they swum? So now they're saying, sum to 10. Now, I could use 2a plus n minus 1d. So subbing in, 12,000 metres. Or, of course, we know on the last day she swims 1,650. I could have used a plus l. And amazingly, we get the same answer. Okay, well, let's really apply a practical point to this one. So after how many days does the total distance that she swum equal the width of the English Channel, which is a distance of 34 kilometres? We need to find, it's a total amount. We know that total amount is 34 kilometres, 34,000 metres. Looks like we're going to end up with a quadratic to solve. Let's tidy it up. Everything divides by 100. That'll make life a bit easier. Okay, multiplies together to give negative 680. Adds together to give 14. If you're going to swim the width of the English Channel under these conditions, which answer are you going to take? Negative 34, of course, because you can say, hey, I did that 34 days ago. All right, so it takes 20 days to swim. Company sales declining 6% every year. Very successful company with 50,000 items. So when will it first fall below 20,000? Well, first term 50,000. This time it's a G metric. So our ratio, now be careful, it's falling by 6%. So the ratio is not 6%, it's 94, yeah. We want to know when is the general term below 20,000. So general term, AR to the n minus 1. So 20,000, well, I've moved it to the other side, so greater than 50,000, 0.94. Log both sides. Now we can bring the power to the front. Divide by log 0.94, but of course, log of 0.94. Therefore, if we change the sign, we change the sign. So 14.8. So n has to be greater than 15.8. We want the first one. So it will take 16 years. No HSC one. Anna and Kay, employed by an accounting firm. Anne accepts employment, initial salary, $50,000. And then the condition is every year, salary going to increase by $2,500. Whereas Kay, she starts at $50,000, but she says, no, every year I'm going to increase by 4%. The first one is arithmetic. A is 50,000, the difference is 2,500. The second condition is geometric. A is also 50,000, but the ratio, and again, it's increasing by 4%, so that ratio is 1.04. First question. In the 13th year, what is Anne's salary? So we want to find term 13. A plus N minus 1D. Substitute in $80,000. So, all right, term 13 in the geometric one, subbing in 61 cents. In 20 years, how much more money will K get? Well, let's see. We've got to find sum to 20. Sum to 20 for Anne is arithmetic. So subbing in 1,475,000. K, 1,488,903.93. So that's an extra $13,903.93. Find the limiting sum. Nice quick question. You'll notice 1D. That's back in the days before they had multiple choice. So possibly you'd see those in multiple choice these days. A is 3/4. The ratio is 1/4. A over 1 minus R. 3/4 over 1 minus quarter. 2003. Find the limiting sum. This one's not as immediately obvious, but we're multiplying by 1 on root 2 plus 1, which is less than 1. So A is 2. The ratio 1 on root 2 plus 1. A on 1 minus R. Ooh, bit of surds. Bit tricky. We'll get there. Whew. 2 plus root 2. Explain why. It's going to be bigger than 1. So it's about 2.414. So no. This was quite a good one. Here's the series. 1 minus tan squared plus tan to the power of 4. Notice question 9. That was back in the days when they had 10 questions in the paper, so towards the end of the paper. A is 1. Ratio is negative tan squared. So it's saying when the limiting sum exists, because depending on what theta is, it may have a limiting sum, it may not. But so we're saying, well, when it does actually exist, find its value. So A on 1 minus R, 1 on 1 plus tan squared, mere mortal answer. 1 plus tan squared, reciprocal of sec squared, cos squared. So we're only going to consider theta being in between pi and 2 and minus pi and 2. Will that limiting sum exist? It will for some. That's why it's asking us for what values. We know it's going to be in between minus 1 and 1. So tan squared or negative tan squared has to be between minus 1 and 1. Which means tan squared is in between minus 1 and 1. But hang on. That means tan squared is in between minus 1 and 1. Got to look proper. That second line, nah, good. But if tan squared is in between minus 1 and 1, then tan is in between minus 1 and 1. So plus or minus pi and 4. Right? Tan is 1 at 45 degrees or pi and 4. Just to give a little picture. Now, I might have gone over the top with my solution here. But if you see the graph here, we know that tan of pi on 4 is 1 and minus 1. There we go. So it's in between those two x values, which we know to be pi and 4 and minus pi and 4. We end up with a y value that's in between minus 1 and 1. So by looking at the graph, I can see theta must go in between minus pi and 4 and pi and 4. So 7a, this is actually in the Year 12 book.